You guys are working on packet 6, and if you want to continue working on packet 6, you can do that. I just wanted to point out. Okay. And I'll just disable it so I do that. You want to be back and follow this, please. No, it's okay. Yeah, where are you? Oh, yeah. Okay, if I can print it out, I'll plug it in. Okay. You need a key to look at, or? No, I do. Okay, all right. You show me all. Sorry, it's the middle passage. Did I give these to you? Have I given this row yet? No. If you're comfortable with these topics, then don't worry about it. But I did see, especially my AB students had a little bit of trouble kind of differentiating with FRQs where, there's rates or when to find area, when to use first theorem, when to do mean valley theorem, when to do average valley theorem, and enough of it where I felt like I was going to present this for AB, and I figured I'll just present it to you guys too in case you wanted a refresher. And then on the back page, I just, grading through the multiple choice, I saw, how often students were getting area and cross section and volume formulas mixed up, the processes mixed up. So that was the back page. So if you want to follow along, you can. Otherwise, continue working on your packet 6. So. Okay, so water is flowing into the tank over a 12-hour period. The rate at which water is flowing into the tank at various times is measured. RFT is the differentiable function. Gallons measured in gallons per hour, and T is measured in hours. The tank contains 150 gallons of water when T is equal to 0. Use the table to estimate the value of R prime of 6. So we know that we have RFT available to us. We want R prime. R prime is a derivative. We don't have a function to find the derivative. Like the next best thing is slope. So we can just pick the nearest order pairs and then do slope between the two endpoints. So my closest order pairs are 5 and 7, or 5, 8.8, 7, 9. So I just did change in the rates over the change in time. My units will change, gallons per hour squared. And what that tells us is that the positive number indicates my rate is increasing, right? The water flow is increasing from 8.8 to 9, and that rate is going to come out to be 0.1 gallons per hour squared. And in terms of the meaning, anytime we have the second derivative, we want to be able to use these keywords. Either rate is increasing or rate is decreasing. So in this case, rate is flowing into the tank. The rate at which water is flowing into the tank is increasing at 0.1 gallons per hour, or increasing by 0.1 gallons per hour at T equals 6 hours. Here, I use my units of gallons per hour because I have the word increasing here. So increasing by this is same thing as gallons per hour squared. Part B, estimate the depth integral using two trapezoids. So we're going to accumulate the rate over this period of time. And we know that if we want to make something go through an integral process, our units will change. So just like how we would be multiplying to find area, we're going to multiply to find area here as well. So gallons per hour times hour is going to rise up to be in terms of gallons. So this is going to tell us how much water has accumulated or added into the tank over this 12-hour period. So trapezoid. At least my AV students have some trouble with trapezoids. One is just forgetting what the formula is. So formula is 1/2 width times height 1 plus height 2. Sometimes I see students wanting to add more than 2 heights if they see more than 2 terms, but we only want to use the heights at the end of the bracket. And another issue I see is we subtract the t to get the width, right? 7 minus 0 is 7, 12 minus 7 is 5, but we don't subtract the heights, we add them. So that's another issue that I see. Students want to subtract the heights, but the formula says h1 plus h2. So we subdivide our intervals into 2 segments from 0 to 7 and from 7 to 12. We find the width of each. We find the heights that are going to be for our formula, and then we add them together. We get 105 gallons of water into the tank in this 12-hour period. Part C, use the data in the table to evaluate the depth integral from 0 to 12 of R prime of t. This looks similar to part B, but we don't have a table of values to pull and use Riemann sums here because we're not at this level. Now, if the R prime table was given to us, then we could use either rectangles or trapezoids. But we have to get from R prime up to R, so we have to find another way to get it into a point where we can actually find this useful. So we have to make that R prime rise up to the R of t level. And the way we do that is, let's just take the antiderivative, right? We have a process for that. We can use first theorem. So first theorem says lowercase f turns into uppercase f. We make it go through the antiderivative process. And then you plug in your upper and lower bound. Same process here. R prime is going to rise up to R. And then we just do R of 12 minus R of 0. We're able to pull that information from our table now. So what does that tell us? We start with 8 gallons per hour. We rise up to 9.2 gallons per hour. Over this 12-hour period, the difference between them is 1.2 gallons per hour. What that means is over this 12-hour period, the rate has increased by 1.2 gallons per hour. So it's kind of like taking that faucet and continually increasing the rate of flow. And we see these numbers increase as well, right? 8 to 8.8 to 9 to 9.3 to 9.2. Over that time interval, we've increased by 1.2 gallons per hour. And that's what this integral is telling us to find. In this 12-hour period, the rate of water flow has increased by 1.2 gallons per hour from 0 to 12 hours. Notice the integral of R prime is going to bring us back to in terms of R, and R is in terms of gallons per hour. So that's why we have our units in terms of gallons per hour. Part D, is there a value where R prime of t is equal to 1/7? I think it'll be much easier if we had an R prime table, because then we can just look, okay, do I see an R prime value below 1/7? Do I see an R prime value above 1/7? Great. I can just guarantee that 1/7 will be hit somewhere between, but that'll be for IVT. We don't have IVT, enough data for IVT. We have something at the R prime level though, but we're only given R of t levels. But we know that R prime is just a derivative or slope away from R of t. So if I can somehow show that there are 2 points that is giving me a slope of 1/7, then I know that there must be an R prime value that's going to match that slope that I find as well. So I see a bunch of decimals, so I'm just going to gravitate towards the whole numbers there. So I do 9 minus 8 divided by 7 minus 0. 9 minus 8 is 1, 1/7. So because my two endpoints is giving me a slope of 1/7, I know that because my graph is connected and smooth, the graph has to experience a slope of 1/7 somewhere along that path as well. So that is basically the process for revaluing. So since RFT is differentiable on the open interval and therefore continuous on the closed interval, my endpoints is producing 1/7. There must be a value where R prime is equal to 1/7, and we can say by mean value theorem. Part E, estimate the depth integral of 1/12 integral from 0 to 12 RT using two trapezoids, using correct units, interpret the mean. If you look at part E and part B, they look virtually identical to each other. The only difference is that there's a 1/12 in front. So let's talk about that. The interval from 0 to 12 will give us the amount of water that's entering into the tank. But dividing by 12 is doing something else, right? So basically, we're taking the total amount of water that's entered into the tank, we're dividing by 12 hours. What that gives us is our average value, our average rate over this 12-hour period. So even though there's an integral involved and we know that integral of RT is going to make it rise up to in terms of gallons, we're turning right back around and dividing by 12. So we're back to gallons per hour. So average value, average rate over this period of time. If you look at your data without even going through that process, you should be able to estimate, okay, 8, 8.8, 9, 9.3, 9.2. If I'm just looking at these numbers, it makes sense that your average value between these numbers will be somewhere in that upper 8 or lower 9 decimal value. And we should be able to look at that and just do a rough estimate. And we see that we get an answer that is consistent with what we are observing. Upper 8, close to 8.8 gallons per hour. This is the average rate of flow in this 12-hour period. So just wanted to go over this because on FRQs, college board, they love to put things that are that look similar to see if students can distinguish the processes. And there's a bunch of integrals all across these problems, but slightly different approach depending on what you have and what they're asking. So just wanted to go over those distinctions, especially when they look so similar. The back page, I'm going to go over the 4 major topics with our unit with area and volume, and that is area between graphs, cross section, volume by this method, and volume by Washer method. So I want to go over each type with you on the back page. Okay, so on the back page, we're just start off by finding area between 2 graphs. So area is just top minus bottom. Now we could also do right minus left, but I would say if you're dealing with area, your default should always start with top minus bottom. If for some reason top minus bottom doesn't quite work out because the graphs don't have that consistent behavior or your equations look weird in terms of y, then you can explore right minus left. But I think we should always explore top minus bottom first. That should be our default. And then go to our next option if that first option doesn't work out. But a lot of times area can be solved both ways, either top minus bottom or right minus left. But notice your formula for area is simpler than volume. There's no parentheses square, there's no pi in front. It is just top graph minus bottom graph. So we see if we don't do top minus bottom, our bounds is also in terms of x, because everything we see is in terms of x. So furthest left is 0, and the furthest right x value is 9. This is meant to be non-calculator, so we have to go through our process of power rule. So we apply power rule, plug in upper and lower bounds, clean up, and then get down to your answer. If this is free response, I would just stop at either of these stages. I wouldn't work all the way down to 18. But if it's multiple choice, you may have to work all the way down to 18 so that you can actually match the appropriate answer. So I keep reminding you that, something like this feels difficult to do, 9 raised to 3/2. How do we get down to a number without a calculator? A lot of students feel like they have to do 9 cubed first, get that large number, and then take the square root. But we don't do it with that 3 first. We can evaluate using the square root first. So square root of 9 is 3, and it becomes a lot easier. 3 cubed is 0.7. Part B, cross section. Okay, so I feel like some students, when they see volume, they just assume that everything is going to get rotated. Unless the problem specifies a rotation around an axis, we're not going to have this for Washer method. So, the volume process that I think we're probably less familiar with is ones that involve cross section. So cross section, with no rotation, we're just building our indicated shape on top of a base. So initially, your area and cross-section process will look the same. But the major difference, so we're either doing top minus bottom or right minus left, just like how we did with area and cross-section. The difference is that with area, you could solve it both ways, potentially. You could do top minus bottom or right minus left. This one, we could definitely do that both ways, but our default should be top minus bottom. So we get to choose, but we should choose or try top minus bottom first. For cross section, there is no choice. They're going to tell you exactly how to draw that base line. So here they say perpendicular to the x-axis. In this case, x-axis is horizontal. Perpendicular will make it vertical. So cross section will be very explicit. You're not going to have a choice. You're going to do whatever process or orientation they're going to tell you. Area, you have a choice, but you should explore top minus bottom first. Okay, so we do top minus bottom because the way that they want to draw our base length. And then we got to decide, okay, what shape do we want to build on top of this base? Is it semicircles? Is it squares? Is it various types of triangles? Or is it rectangle? We're dealing with squares here. So after we build our base length, which looks a lot like the top minus bottom from area, we're now taking that and putting it into the appropriate area formula. So a lot of cross-section formulas look like this, base squared, but with a different coefficient depending on the shape. In this case, it's just a square, so there's no coefficient, just base squared. So we put the 6 minus 2 root x in for the base length, and then we get that area. So if you get to this point, you've gone to the hardest part of the problem. After this, you're just taking the integral and putting integral around that. No pi. The only time you have pi involved with cross section is if you have a semicircle. This one is only asking you to set up the problem, but this could very well be solve the problem by hand as well. Thank you. Which one?
The other one I texted you yesterday. No, it's 6 minutes.
Let's see, what did you send me? of intervals uniforms.
Yeah. I'll- I'll-
I don't have that right now, but um, I can also just take the quick intervals unit. And transfer that over to the intervals space. But yeah, we could do this problem using power rule if we expand it all the way out and plug in 0 and 9, but this one is only asking us to set it up. And then part C, now we see words like rotation involved. So when there's rotation around an axis, now we're going to be involving either disk or washer method. So in this case, we have a horizontal axis. There's obviously a gap. We need two radius. The radius is going to come out vertically. So that means it's an easier setup, top minus bottom. We already have the equations ready for us to use. Make sure if you're doing washer method, big radius gets own exponent squared, little radius get their own exponent squared. And then your bound still stays left x value being 0, right x value being 9. If you're having trouble deciding, wait, should I be doing left to right or bottom to top? Look at your variables, right? If your variable is in terms of x, you want your bounds in terms of x. That means as far left and as far right. If your bounds is in terms of y, then if your expression is in terms of y, then your bounds also in terms of y. You want to find the lowest and highest y value. For part D, now we have a vertical axis of revolution. So vertical axis means my radius has to come out horizontal, since radius and your axis will always meet at a T. So if I have a horizontal radius or horizontal base, you know there's additional setup required. We can't use the equations that they give us. We have to build them into a different form. So y equals 2 root x needs to be rewritten. Solve for x, we get x equals y over 2 quantity squared. So now we have a new name for this curve. This y-axis is x equals 0. The axis of revolution is x equals -1. They all have the form of x equals. Now we can do right minus left. This problem is also washer method. We also have a gap here, so we need big R and little r. But if that dotted line was right up against that y-axis, then all we need is big R, and that will be enough. But in this case, we need little r as well. So right minus left for both. Notice your expression. These are all y variables showing up. So my bounds need to also be in terms of y. Lowest, the highest y value. Yeah, just wanted to do a quick overview, just because this is based off of what I saw students struggle with on the recent multiple choice test. So just wanted to run through those. Okay, so continue working through packet 6 for at least the next 10 or so minutes. So we're for the first time to use the term, but so we're just going to replace n with n plus one into k as well. So I'm just figuring out what k value will allow this value to turn out to be less than or this number. So I just cross multiply it, solve it.
Oh, okay, yeah, because I was confused with the K, but
Yeah, you can use n as well. Yeah. Oh, I just duplicated that. So there's limits. I just did I could find which count to practice grading, homework grade and should be yeah. It's yeah, so once you turn 35 by 6 column, replace the oh, this may be